I'm recording this video is for my son's classmate for the chemistry class. Myself is not good at chemistry, but I just try to explain this is a mathematical way, the mathematical aspect, because I'm more familiar with math. Okay, let's start. Just for the explain, I'm not good at chemistry at all. Okay, so for mathematical the aspect, for I would say this will be the wave. So we have the wave wise we have there's a from here from this point from this point to is one complete one cycle up to here it's a one wavelength. So frequency means the same from the certain same amount of time. How many whole period, one cycle, how many cycle is completed? That will be the frequency. For that matter, this will be more frequency. This in same length. We have 1, 2, and 2.5 of frequency. But meanwhile, this will be one from here to 1 is a 1, 2, 3, 4. 4 times and more. This one will be a little more. 1, 2, 3, 4, 5, 6, 7, 8. So we have more frequency. Higher frequency means it has more energy. So between energy and the frequency, they have as a relationship that is always that is in the that's a certain time of ratio. So the frequency always have a multiply the constant value. We can find out their energy. So that's no matter what type is proton, what type of wave, electric wave, as long as this is our higher frequency has more energy. So that's let's see this question then. Let's erase this for now. Okay, so why is doing this? So equation wise, we have few equation as provided here. So I'm going to explain this. The energy, so I just explained energy, it's multiplied by, this will be the Planck's constant multiplied by the frequency. That is that we can calculate the energy. This will be Planck's the constant. We don't need to worry about this already given. As long as we know the frequency multiplied by the constant, we easily find out our energy of the proton or any electron wave. Then that is the first equation, really in the simple easy question in relationship. And the next one we want to look at here, second equation. As we can see here, the c is the speed of the light. Speed of the light, that means how far the speed of light can go per second. Then per second, then we want to see how this is in the one from here to here is one of the wavelengths. The measurement is one wave one. This is this measurement is in wavelength of in meters, and if per second we have this many time of a frequency, we can multiply it by the length of the wave. We multiply by the frequency, we can find out the speed of the lights. So there's the speed of the lights is equivalent to this will be the wavelength multiplied by the frequency. Then we can come up here. Earlier equation, first this formula was given. Here is the frequency multiplied by the constant. But if the situation we don't know the frequency, then we can from second equation C equals lambda multiplied by the V frequency. We want C equals lambda multiplied by frequency. We can divide by lambda on both sides. Then our frequency we can calculate by the speed of light divided by lambda. So the frequency in here, frequency V, we can substitute with this expression. That's how we obtain the third equation. Original equation was the constant multiplied by the frequency, but instead of frequency, we substitute with the quotient or ratio of this is speed of light divided by the lambda. That is the wavelength. Alright, so how we can using this equation to solve problem? Let's go for check a few sample question or word problem. This practicing question is given down below. So first question is here is a proton has a frequency V of 2.68 times 10 to 6 power. I'm not going to give you answer, just how we can approach this question. So what's in the equation we can use? Calculate the energy. So energy, as you see, we have two equations as given. Here's two equations. First one is HV, the constant multiplied by the V, or constant multiplied by C divided by the lambda, the wavelength. So this question directly give you the frequency. So we have frequency, therefore we just again can go calculate by the first equation, the equation they given. This is H times the frequency. H was the Planck's constant, so 6.63 times 10 to negative 34th power. JS, the unit, so multiplied by the frequency is 2.68 times 10 to 6 power hertz. So I believe you guys can able to calculate this and just make sure you get result as scientific notation. That's all we need to be careful for this first question. Let's go check second question. The calculated energy and the wavelength of a proton of the lights with the frequency V of 6.165 times 10 to 14 power hertz. So calculate energy. So calculate energy, first equation we see here, we need a frequency, but this second equation didn't give you, they give you frequency. Okay, so that's a good idea. Then we can, since we have frequency, we continue using same equation. So our H 6.63 times 10 to negative 34th power JS times the frequency 6.165 times 10 to 14th power hertz. That's the first the question for the energy. And the next we need to calculate wavelengths. Wavelength lambda we can calculate by, we checked earlier, lambda calculated we can calculate because the speed of length is equal to lambda multiplied by the frequency. That means our frequency wavelength we can calculate by the speed of light divided by the frequency. So we are going to using that one, speed of light divided by the frequency. Speed of the lights R is given 3.0 times 10 to 8th power meter per second divided by the frequency is given here 6.165 times 10 to 14th power hertz. That's the for the question. Second question for wavelengths, and the first in this one is we are calculating the energy. Okay, let's go check the third question. Calculate the frequency and the energy of the blue lights of the head that has the wavelength of 400 nanometer. So we have to really be careful what type of equation our units for when we're using the equation. So mostly we're using second for the time, for length, so it's a way using meters. For this equation, they give you wavelengths of 400 nanometer, but it's not meter. For our equation given, we have to using the wavelengths in the meter. So first, we want to convert to our 400 nanometers, convert to meter. So wavelengths equals 400 nanometer. So wavelength, the nanometer we convert to meter. But because this is a 400 meter, I just put a scientific notation 4.0 times 10 square nanometer. But convert to meter, we from nanometer is a micrometer, micrometer to millimeter, millimeter to meter. Therefore, we should 4.0 times 10 to square. I need to multiply 10 to negative 9th power. 10 to negative 9th power to convert to this one question 3. Yes, and so 3 point, okay, question 3 calculate 400 meter. Yes, I think that's okay. So times 10 to nanometer. Let me see, nanometer, micrometer, millimeter, meter should be 10 to negative times power. Then to be 4.0 times 10 to negative 7th power meter. We already convert to the meter. Now calculate the frequency. So frequency was V. We want to calculate V. Still go for same. Our speed of light was the wavelength multiplied by the frequency. Therefore, frequency we should be able to calculate by speed of light divided by the frequency. So I'm going to using that formula in the equation. C speed of light divided by the wavelength. Then this will be speed of the light 3.0 times 10 to 8th power meter per second divided by our this would be wavelength is 4.0 times 10 to negative 7th power meter. Then this will be 4.10 to negative 7th power meter. So I'm not going to calculate. You guys calculate by yourself. Now we are going to for question 4. Calculate the wavelength and the energy of the light that has the frequency 1.5 times 10 to 15th power. So what we have here, they give you frequency and they want you to find out the wavelength and the energy. So wavelengths, we did early, this frequency wavelengths, we were able to calculate by the speed of light divided by the frequency. They have frequency given here, speed of light 3.0 times 10 to 8th power meter per second. And we have to divide by the frequency, 1.5 times 10 to 15th power hertz. Okay, that is you guys get the answer, and that is the wavelength. Now we need to calculate the energy E equal to HV. H is we already given here 6.63 times 10 to negative 34th power joule seconds times the frequency 1.5 times 10 to 15th power. That's how we can find out the energy for this one. And the question 5, photon of the light has the wavelength 0.050 centimeter. Calculate the energy. Okay, so what we so far we doing our energy was calculated by the constant multiplied by the frequency. But this question doesn't have frequency, only give you the wavelength. So wavelengths with our wavelengths we were able to calculate the frequency. So frequency was able to calculate speed of light divided by the frequency, wavelength. So we want this the V, instead of V we want substitute this. That's how we got another equation for the energy. It's equal to H times C divided by the wavelength. Then we know this will be H constant value was 3.0. Constant value in Planck's constant value 6.63. 6.63 times 10 to negative 0 power joules s times speed of light times 3.0 times 10 to 8th power meter per second. Have to divide by the wavelength. But there's another problem. Wavelength is given unit by centimeter. So that one, I'm going to make a scientific notation as is 0. Nope. We cannot have 0.5. Should be 5.0 times 10 to negative second power centimeter. In order to convert to meter, I'm going to 5.0 times 10 to negative second power as is. We just copy down. In order to convert to meter, I'm going to multiply 10 to negative second power again. Meter to centimeter, that is a 10 to second power. So from smaller unit convert to bigger unit, I need to divide by. In other words, I multiply negative and 10 to negative second power. There, that's units in meters. So 5.0 times 10 to negative fourth power meter. So I'm going to using that wavelength 5.0 times 10 to negative fourth power meter. So in here you see the units, we can cancel out. This cancel out. As final, we have the joules as a unit for energy, and the numbers you can calculate by self. Next one, question 7. Calculate the total energy of the gamma, the radiation having the wavelength 3.0 times 10 to negative second power meter. That's good. They give a unit as meter. For this will be wavelengths. Then we need to calculate energy with we don't have frequency. That's why we want using same the equation. We're using same one. if we have a frequency, we just using this h times v, but we don't have the frequency, we have to calculate that. So h c divided by the lambda. So h is 6.63 times 10 to negative 34th power, js times 3.0 times 10 to 8th power, meter per second divided by our the wavelength 3.0 times 10 to negative 12th power meter. Okay, then it's already done question 7. Then question 8, calculate the energy and the frequency of the red light having the wavelength 6.80 times 10 to negative 5th power centimeters. So I'm going to convert this for now. Convert to the meter. 6.80 times 10 to negative 5th times negative 10 to negative 2nd power meter. Therefore, 6.80 times 10 to negative 7th power is meter. So we have, they want you to find the energy and the frequency, but only give you the wavelengths. So we just go to using same one. We don't have the frequency, we just have to using this formula, hc over lambda. But that number is same as how to calculate the same as the previous question, but they also want you calculate the frequency. Therefore, frequency v, we can calculate just this portion. This portion is same as the frequency. So I'm going to see speed of light divided by the wavelength. So speed of light 3.0 times 10 to 8th power meter per second divided by the speed, and that's a wavelength 6.8 times 10 to negative 7th power meter. Okay. Problem 9. Wavelength of the green lights from the traffic signal is centered at 5.20 times 10 to negative 5th power. Okay, so let's convert this again. So 5.20 times 10 to, this time I just go for negative 7th power meter. Okay, that's the converter unit. That's wavelength. They want you find out frequency. That's easy. Frequency v was speed of light divided by the wavelength. Speed of light 3.0 times 10 to 8th power meter per second divided by 5.220 times 10 to negative 7th power meter. So meter cancel out, yes, as result is 1 over s to negative 1st power. In other words, that will be equivalent hertz. Last question. Not too bad. Last question. That's the frequency of the light has the wavelength, the identified type of electromagnetic radiation. So I'm not going to identify, I don't know what is the each difference, but we can calculate the frequency. Frequency same as our earlier one. So this is speed of light divided by length of wavelength. Speed of light 3.0 times 10 to 8th power meter per second divided by this wavelength 4.25 times 10 to negative 9th power meter. Yes, so you guys all have a calculator, get the answer. That's it. So good luck.